I want to talk about, I want to change simple problems. Because those two problems I thought about for quite some time, and I felt I couldn't find good problems for those two. So let me talk about these two sample problems first. My remote control. Yeah. The first one is that Wronskian. That Wronskian problem, number 6. Yeah. Because this one, it could be used as a concept problem. If it's for a computation problem, I couldn't find an interesting problem, meaningful, interesting problem. So I want to replace this by another problem in this same Module 2, Part B. Yeah. But that one, remember this one, question number 3 in our homework assignment number 2, that is from part B of Module 2. In that part, actually, it's a theoretical part. So we do not have many computation questions. Existence, uniqueness, we do not have a lot of choices on the computation problem. So I picked this one. Yeah. Let me talk about this one first. I look at some of you before the class, because when I talk about the computation questions, the details, I need to know how did you do it. So what specific ways you use to solve those problems. So I look at several students. This one, my intention is, because in that part I give you the mean inequality, right? Yeah, but I look at 4 students. None of them use this mean inequality. Yeah, it's okay, because when you learn calculus, when you calculate the maximum, you use the derivative, critical point. Yeah, so that no problem. Yeah. So, and in this part I introduce mean inequality. Yeah. We can use mean inequality to solve it. You do not have to use it. The reason I give it to you first is it's very important. It is a very famous inequality. And in our real world, it is very useful. Yeah. So I like you to know it, at least. Yeah, but when you work, because you didn't have a lot of experience, so you do not feel comfortable to use it. So you just use the derivative, solve it, no problem. Yeah, full credit still. Yeah. All right. Here, for our homework question, I make that version from 2 variable to 3 variable. In our class, we did 2 variable, right? Now, we did two variable version. Now, so this one, I make it to 3 variable version. Yeah. But when we apply, the 3 variable version is the arithmetic. AM means arithmetic mean. AM, this is the arithmetic mean. Greater or equal to the geometric mean. This is the geometric mean. Yeah. So then, when inequality holds, when x equals y equals z, inequality holds. All right. For this question, because this question, we use this way. Because we are given a plus b is a fixed number. But a plus b, for our mean inequality, we need to have 3 variables, right? But a plus b, only 2 variables. But our dimension, we have 3 dimensions, right? Yeah. So we need to split that a into 2 terms, 1/2 of a plus 1/2 of a. Then b, we apply mean inequality on these 3 terms in this way. Then we can find find a solution. Yeah. All right. Now, move to our midterm. Midterm, because I replace this one by this one. Yeah. So the midterm, I need to do a different version. Okay. Yeah. So here, this one is a 3-dimensional box. So I generalize it to 4-dimensional box. 4-dimensional box. Okay? Yeah. It's hard to draw it, right? 4-dimensional figure. How to draw that box? Yeah. But in our abstract thinking, it exists. Yeah. High-dimensional. You know. So in math, people study high-dimensional objects a lot. So here, 4-dimensional object we study. Yeah. All right. Then, four different dimension. Okay. Then, yeah. So I use the similar way. Okay. Yeah. So A, 2A, 3A, for example, right? That B dimension. Yeah. So then I ask you to maximize. We have A plus B as a constant. Okay. Yeah. Then you need to maximize the volume of this box. Yeah. Although you can use calculus, no problem. Calculus, yeah. All right. Yeah. But this mean inequality can also be extended to 4-variable case. So x plus y plus z plus w over 4. This is the arithmetic mean greater or equal to geometric mean. 4th root of x, y, z, w. Yeah. No problem. Yeah. Inequality holds for x equals y equals z equals w. Yeah. 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 So that's this question. All right. Yeah. So 1 of the 10 questions. Yeah. Not too hard. Yeah. Yeah. So I look at all those students using the calculus derivative. Yeah. So all correct. Yeah. So pretty easy. Yeah. So I hope everyone should not miss this one. Yeah. So, yeah. All right. Here, when I go through all these questions, I want to make sure you do not miss too much. Okay? Yeah. Try to get the maximum you can get. Yeah. All right. So that's this one, replacement. Yeah. The second one, replacement, is that PDE question. This one, yeah. This one, I look at it. So if I couldn't find a good problem, if I try to make, following this topic to make it, typically I just repeat the same example. So not interesting. So now I replace it. Replace it by the electric circuit problem. So this is our homework problem number 11. Homework assignment number 2. Question number 11. Electric circuit, Laplace transform. Yeah. So replaced by this one. Yeah. All right. Yeah. So about the Laplace transform calculation, then I delay. So I will explain. Because this one actually, other than calculating Laplace transform, yeah. Other than that, so that part relatively hard, yeah. But not too hard, relatively hard. Yeah. In my questions, I try to make the formulas not too complicated. Yeah. Should be easier than our homework assignment 2 questions. Should be easy. Yeah. All right. Yeah. But this question, there is another problem. Yeah. So I haven't looked at closely in your solutions. Yeah. But here I want to talk about that. How to use this initial conditions in a right way. Initial conditions. Yeah. There is some important consideration there. Yeah. All right. But I delete that topic. Yeah. All right. Next. Yeah. Based on the topic. Yeah. So I talk about topic by topic in this midterm. Yeah. The question, Mark?
So are there 2 circuit problems?
Yes, 2 circuit, but different methods.
What's
Yeah.
the cost?
Yeah. Right. Yeah. Yeah. So we'll get there. The first one, this one, reactance way. So I want to talk about this because I look at your solutions. Yeah. Look at your solutions. I feel there are some problems. Yeah. Not big problems, but there are some problems. So we want to solve this problem in a right way. So you can save your time, save a lot of time. Second, it's easier to avoid mistakes. Yeah. So because if you use the relatively hard way, it's very easy to make many mistakes. Yeah. All right. So let's look at this question. Yeah. So this one. Remember our question number 9 of homework assignment number 2. Yeah. So this one. Yeah. So let's look at the solution part. Yeah. Because the equation set up so very easy. Yeah. So then, some students I noticed. One student solving all these ODE using Laplace transform. Yeah. It's okay. Yeah. Because in this question, I didn't say which method to use, right? So then you have freedom to choose your favorite method. Yeah, but for some of the question, when you use Laplace transform, the calculation actually harder. Yeah, much harder than the non-Laplace way. So our normal way. Our normal way actually pretty easy. Yeah. So here I want to recommend this. Just like our example in our class. But when I look at those 4 students, it looks like none of the 4 students used our example in class. So here I want to highly recommend the method used in class. Yeah. All right. After you get this equation, definitely you need to take derivative, right? Yeah. So sorry. Yeah. I forgot to write the derivative version. Yeah. Just second order. Yeah. Q. So we know plus I over then derivative E0 omega cosine omega t. Yeah. So let's work on this standard second order ODE. Yeah. Standard or not important. Just in this form. This form more friendly. Yeah. Standard form may not be the best. Yeah, because standard we need to do division by this L. Yeah. So here, do not do that division. Keep that. Yeah. All right. Because we need to apply formulas. Yeah. All right. Next, let's start apply formula. First, we calculate the reactance. Yeah. Yeah. So people define a concept. Yeah. So this S temporary variable. We calculate. Omega known, right? Yeah. Omega 314. Omega, right? Yeah. So, yeah. Omega times L, all given. Omega times C. Yeah. So you calculate. You get this S. Yeah. Temporary variable. parameter first. Then IP, yeah, because the solution you have IH and IP part, right? Yeah. IH plus IP, that's your final solution. IH part, yeah, so you can get from the, these three terms easily, yeah. So, characteristic equation, yeah. So the main work is at IP part. Yeah. IP part, yeah. So this form pretty simple. So we use, undetermined coefficients, right? AB coefficient. So we, yeah, remember by the choice rules. The first one, basic rule of choice rule. Yeah. So we only need to determine little a, little b. Then you get IP. All right. Then little a, there is a formula, right? Yeah. You plug in. Yeah. Yeah. So that's the formula. Yeah. So S, you have that S. Little b, yeah, plug in. Yeah. So you can use calculator. Then you get answer. You put together, you get an answer. Yeah. So this is the easiest way and the fastest way. You do not need to. I saw some students, they did the calculation explicitly. IP prime, a long formula, right? IP double prime, another long formula. Then calculate, very messy. A lot of calculation, a lot of time. Then very easy to, get a mistake here and there. Yeah. Yeah. Here, yeah, very fast. Saved a lot of time, and you won't miss it. Right? You just plug in. Okay. Yeah. So I hope the whole class. Yeah. If you use this method, I think you have the best chance to get full credit. Yeah. Because when I look at your work, even those students, some very messy way, yeah, but your calculation, some point here and there, I may need to take 1 point here, 1 point there, right? So it's hard to get full credit. So that's the point. Yeah. All right, yeah. So that's I strongly recommend this method. Yeah, fast, 5 minutes should be enough. Okay, yeah, just plug in calculation. You use online calculator to do the calculation. Yeah. All right, yeah. So this is one topic. Yeah, very important. Then our first two, I hope everybody, you should not miss the first two questions. Okay? Yeah. The maximum 4-dimensional box and this one. I hope nobody missed these two questions. Yeah. So easy. Yeah. All right. Then, next topic. Reduction of order. Yeah. We will have one question. Actually, this question also pretty easy. Yeah. So first, let's look at our homework question. Actually, our home question a little harder. Yeah. But our midterm question, I made it much easier than this one. Yeah. Much easier. Yeah. So based on the technique described on page 53, we need to introduce this variable z equals dy over dx or y prime. Okay, all right. Yeah. Then we need to calculate double prime. Yeah. So here, let me, although I look at all those 4 students, it looks like all of them got this one. Yeah. So nobody missed this one. Yeah. So you did quite well. Yeah. So here, I just want to say something about the background of this method. So when you use it, you should feel comfortable. I hope you won't have question in your mind So you have doubt. Why we can do this way? Yeah. Here, actually, we can do this way. Yeah. Some background. Go back for you. This question, you can see no x variable. X variable hidden, right? Yeah. Because why need to use x variable, right? Y equals y of x. So the x variable here hidden. It exists, but hidden. Yeah. So in your mind, you have it. Okay. Yeah. All right. But then, this technique, actually, you change the variable. Yeah. Because x does not appear, then in this original equation, treat y as the variable. So this ODE, make it based on the y variable. Yeah. Original ODE based on x variable, so now there is a change. Yeah. Here I want to explain why this change works no problem theoretically. No problem theoretically. Yeah. All right. You know composite function, right? So actually here we use the composite function view to see it. Composite function. Composite function view to see this kind of variable substitution. All right. Yeah. Let's say, because we introduce a z function. Z is a function. Okay, so dy of dx. Z is a function. All right. So z function in this way, z should be a function of x variable, right? Yeah. If we define z in this way, z should be a function of x variable. How about we use our imagination to look at a z as a composite function? Yeah. So here, there is a step. Yeah. Look at z as a composite function. Composite function. How to see that? So z, first, z composite with y first, then y with x. Okay? Yeah. In this way. All right? Yeah. We look at it in this way. Yeah. How can you do it in this way? How can you do it in this way? So here, we hope we can do it. Yeah. Because in math problem solving, people need to use your imagination to get things work, right? Use your imagination. So you need to make a plan, right? Yeah. So here, I may like to use, playing chess. Yeah. So playing chess, you have usually good chess player. Every move you have several plans, right? It's not one plan, right? Yeah. But some of the plan may not work well. Some of the plan works well. Here in our math problem solving, we have the similar situation. When we solve problem, we have several plans. Some plans may not work. So here we use this composite function view as one of our plans. It may not work, because it may not work. But under special situation, it works. It works under special situation. All right, so here, it has a chance to work. So if z can be written, because if, so If z can be written as a composite function like this one, then we can write z as z of y, right? Because y contains x variable, right? X variable is inside y. So y carries x variable. So our z function will only need to cover y. So you don't need z function, you do not need to worry about x. You just, responsible for y. Y will take care of x. Yeah. Use this kind of understanding. We hope we can do it. It may not work. Okay? So this plan may not work. Sometimes it doesn't work. All right? Fortunately, the equation given in this one, x does not appear in this situation. This method could work. In this special structure of our ODE, so this method would work. Yeah? So we don't need to deal with x. Okay? Yeah. Yeah. So I hope this explanation just help you get things smoothly. Yeah. So when you do the work, you should not have any doubt. Yeah. Theoretically, no problem. Okay? Yeah. Otherwise, you may not feel comfortable. Why can work in this way? Yeah. All right. So then the remaining, chain rule, pretty straightforward, right? So then, but this step you need to do apply another technique. Remember extended separable. Yeah, we have that. Yeah. The good thing is, most of you can also do that. Yeah. Yeah. So this one, yeah, because this introduce u equals z over y. Yeah. So this u, the good thing is when you write z equals u times y, you take dz over dy. Yeah, because this time you want to use y as the variable. So du over dy time product rule, right? Times y plus u. Yeah. And the good thing is this is u cancel out. Yeah. So there you. But in my midterm question, yeah, here I will post the solution. After this class, I will post my solution. Yeah. So for the details, yeah, so you can study, my solutions. Yeah. All right. But for our midterm, actually much easier than this one. Yeah. Midterm, actually, the question I gave you, you do not need to do the second round. That extended separable part. Yeah. After you do the substitution, you get a separable quickly. You just solve it. Yeah. So the midterm much easier than this one. Right? Yeah, much easier. Yeah. So there. So this question, I think nobody should miss this one. So simple. After one simple substitution, then you're almost there. Yeah. So then the first three questions, yeah, everybody should get these first three questions. Yeah. 30%, that's 30%. All right, yeah. All right. Then the next question, yeah, next topic, choice rules. Yeah. Choice rules. Yeah. We will have one choice rule question. Yeah. In our homework assignment number 2, we have 2, yeah. But in our midterm, I only pick one of the 2. Yeah. Here, let me talk about a little bit. Yeah. Choice rules. The first choice rules, yeah. So this one, yeah, because we only need to write YP, right? Yeah, the choice rule, the main step is that YP step. Yeah, YH, very easy. YP, this one, yeah, because here you can see we have double root, right? Yeah, lambda plus 3 squared characteristic equation. So y equals -3, it's a double root. Double root, then that double root appears in this e function. Then our choice, we need to apply modification rule, right? Yeah. So this one, we need to apply modification rule. The question, how to apply modification rule? Yeah. The right way is this. Ax cubed e to the plus b x to the fourth. This form. Yeah. So why is that? Yeah. So you think in this way, because two terms, we use the sum rule, and we can do separately, right? Yeah. So let's do one by one. The first one, let's look at what form should we use for this one. Yeah. Based on modification rule, when we see this e function, we should use the x squared times, because double root, right? Double root, so we need to use x squared times this e function. Okay? Right. But we have extra x, that's why we need x times this one with some undetermined coefficient. That's the first term. Similarly, second term, yeah, because x squared, right? X squared. So that's why we use b times x to the fourth. This square times this square here. So we have this. After you get this right form, you plug in, just use the online calculator to calculate derivative, double derivative. Yeah. You know, by hand calculation, although no problem, first time consuming, second very easy to make mistakes. Yeah. 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 So yeah, this one very easy, but we will not work on the similar question in the midterm. Yeah. Midterm, I took the second one, not this one. Midterm, I took this one. Okay, yeah. This one, yeah. This one, but in the midterm, I do not ask you to do this initial value part. Yeah. Now you need to just plug in and determine coefficients, right? Yeah. So save you some time. So we just find the general solution. So then we're done. Okay. Save some time. Yeah. Not that important. Yeah. Not that important. Yeah. All right. But yeah, first yp should take this form. Yeah. Yeah. Correct. But I look at your, those 4 students, the solutions. All of them got this form correct. Yeah. All right. But here I want to, when you use this way, so is it based on your natural thinking, or did you try to apply the choice rules? Here, this question. I want to answer this question related to the choice rules. Yeah. Is there any contradiction? Yeah, so this form is correct. Yeah. But when you use this correct form, is there any contradiction with the choice rules? Yeah. I want to answer this question. Yeah. If some of you have doubt, so I try to answer, clear your doubt. Yeah, here. All right. No violation. No violation. Yeah. So why some possible violation? Because some of the students may ask questions like this. When you look at the left-hand side, when you calculate the characteristic equation, you have a double root, right? Yeah, double root. So y lambda equals -2. This is a double root. But this double root also appears in the e function of the right hand side, right? If somehow you want to apply the modification rule, right? Yeah. But here there is a sine 2x. Sine of 2x. When it changes thing. Yeah, because if some students want to connect to the choice rules and think about if we apply the modification rules, we should use x squared times e to the negative 2x, right? Then it will be wrong, all right? Do not do it in that way. This part, there inside a cosine 2x plus b sine 2x, if you use this way there, it will be wrong. Yeah. So let me explain why this way. Yeah. The reason is, remember the sine function, cosine function, they're also e function, right? Yeah. By Euler's formula, right? So here we need to use Euler's formula. Okay? Yeah, let me only write this sine. Yeah, because cosine we can also write sine e to the x minus, right? Yeah, cosine is plus. So minus I e to the negative. Sorry, I. Sorry. Yeah, sorry. Yeah. I. Right? Yeah. Yeah. Because Euler's formula is this. That's Euler's formula. Then sine we can write in terms of e. Then here 2x, yeah, sine 2x can be written as 1/2 e to the 2xi minus e to the negative 2xi, right? Then you multiply another 2x, so what you get is, so this term here, you get 1/2 e to the negative 2x plus 2xi. Yeah. X you can factor out, right? Yeah, because x is the variable part. We should factor x out. All right. Negative 2 plus 2i times x. How about that? Right? Because constant coefficient we should put together. Yeah. Minus e negative 2 minus 2i x. Right? Yeah. After you write this way, then this is the constant in the exponent part, right? Yeah. This is the constant value. So when you apply the choice rule, you should compare your lambda double root negative 2 with this constant. Then they are different. If they are different, we do not need to use the multiplication rule, right? So this tells us we should use the basic rule. We do not do modification. Apply the basic rule, all right? Basic rule, the first term you just multiply A. Second term you multiply B, okay? You do not need to multiply that x squared. No x squared thing. That's the basic rule, okay? Then, yeah, because this is for your thinking. When you write, yeah, because this way, that's the equivalent to this way, right? When you write, do not really use that form, because it contains complex numbers. Do not really use that. That's for your understanding. So this part is for your understanding. Okay? Understanding to convince you, you should apply basic rule. Do not apply modification rule. That's the purpose of this step, right? Yeah, because for the convenience, we should use this way to write. This way, when we write in this way, it matches the basic rule, right? So this way is the, so we use the basic rule. Okay? Yeah. So that's the reason it's correct. Okay? Yeah. Try to clarify, some potential doubts. Yeah. Here. So then, you apply calculator to do the calculation. Okay? After you get a correct form, do online calculator, derivative, adding together, copy, paste, yeah. So very fast. Save a lot of time. Yeah. All right. So this question, I think nobody should miss this one. If you see a similar question, so I hope, because you know how to write this YP function. Then you apply online calculator to calculate. Okay? Yeah. So the first 4 questions, I feel nobody should miss any of the first 4. Yeah. All right, yeah. Then 40%. Okay? Yeah. Already 40% in your pocket. Okay? Yeah. The remaining, not very hard. Yeah. Oh, we have several from the Module 1, right? We have 4 questions from Module 1. Yeah. But today I do not talk about Module 1. Yeah. Not hard, Module 1. Yeah. I do the modification slightly. If I talk about it, it should not be a problem. Module 1. Think about Module 1, 40%. Module 2, 60%. But you can see these first 4, you already you get 40% from Module 2. From Module 2. So not hard. So I try to make our midterm not too hard. Yeah, as simple as possible. As simple as possible. Yeah. Because your time is very limited. Yeah. Very limited. So it should not be very complicated, very time consuming. Yeah. All right. Then Laplace transform. The one important thing is Laplace transform. Yeah. Laplace transform regarding the computation techniques are relatively hard. Yeah. Compare it with other calculation work, relatively hard. Yeah. So I want to talk about a little bit. Yeah. All right. All right. Yeah. So let me do one simple example. Then we take a break. First one, this question. Yeah. Actually, this question, not very hard. Yeah. But you need to do some work. Yeah. All right. Yeah, so this one, look at the structure. There is another way. Yeah, I saw a solution using a different method. Yeah, it's okay. Yeah. So let me talk about that method first. Because the function, capital F function, so this is capital F of S function. Yeah. This capital F function can be written as a product, right? A product function, okay? 1, so you can write S squared. Second, you can write S minus 2 pi. Yeah? Then, the first one, the inverse Laplace transform, you can find it easily, right? $20t, right? $20t. The second, this one, shifting theorem, right? Yeah. Second shifting theorem. Right. Yeah. You have one. Actually, U function, right? Yeah. 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 So U function. Right? Yeah. So then, after that, do convolution. These two functions do convolution. Yeah. So one method is like this. Yeah. But this one, because convolution, you need to calculate integral, right? Yeah. Calculate integral. Yeah. Yeah. So, yeah. Here I just say, some people use this way. It's okay if you feel comfortable. It's okay. I prefer we do decomposition on the fractions. Decomposition. Yeah. So if you can handle that part, yeah. So that just do the decomposition. Yeah. Because we cannot get around decomposition. Yeah. Decomposition, most of the time we need to do fractional decomposition. Yeah. All right. So here, the decomposition part. Yeah. Write this way. This one. First, yeah, denominator common factor s squared out. All right. Then I write this way. I hope you can see this one. 20 over s out. Why I factor this 20 over? Because inside the brackets, I want to structure s times another linear function of x. Product of two linear functions of x, s. In that way, I know how to do decomposition. So that's why I like to, put them together inside a pair of brackets. Yeah. All right. After that, yeah, do decomposition. Yeah. Remember? Yeah. So I talk about, so here, let me review. Yeah, some students may still have doubts on the decomposition technique. Yeah. Let me do one here. S times s plus a. If we do decomposition on this structure. All right. Here, when we split two terms, so here, in our mind, this we treat this form as a positive form, because there is no negative sign. Yeah. Although the form positive, the value could be negative, right? Yeah. So here we're not talking about the value. So here we're talking about the form. Form is a positive, okay? Because we do not see negative sign. Form is a positive. So then, when we split, we should maintain positive, maintain that, okay? All right. To get a positive object, yeah, we can call it a positive object, okay? Yeah, not positive value. Yeah, all right. Positive object. So we should use a bigger object minus smaller object, right? Yeah, then it's positive. Bigger object minus smaller object. Bigger one, a fraction with small denominator is bigger, right? Yeah. A fraction with a larger object, s plus a, yeah. If both positive numbers, the denominator is larger, right? Yeah. Here we can treat, the form is larger. How about that? Not value larger. Value may not be larger. All right? Yeah. So S plus A. Then, so we get a positive, but when you do common denominator subtraction in the numerator, you have A at the numerator, right? So you need to divide it by A to balance the formula. Yeah? That's the way. Yeah. So we can do the fraction decomposition, splitting simple fractions. This kind of simple fractions we can split like that. So here we using that way because s minus 2 pi smaller than s, right? Yeah. So the first fraction, the denominator should be smaller. Yeah. So we put that first. S minus 2 pi minus, yeah, smaller than s. Yeah. In this way, we can keep positive, right? The subtraction, the result, positive. Then the numerator 2 pi, yeah, but we need to divide it by 2 pi, right? So 20 cancel out 2, so 10 over pi. Yeah. That split. Okay, all right. Then after that we multiply out. Oh, sorry. Yeah, another round. Yeah, actually another round. Yeah. So 10 over pi s times s minus 2 pi. Second, 10 over pi s squared. This one you split another time, right? Another time, another split. So you have 3 terms. Then you apply inverse Laplace transform one by one using basic formulas. Yeah. So for the questions using Laplace transforms, the main part is at the fraction splitting step. If you get that part done, yeah, so you're almost there. Just apply basic formula one by one carefully. Yeah. Yeah. So if you can do this decomposition, splitting part, then you complete at least 1/2 of the work. Yeah. Remaining half just apply suitable formulas. Yeah. All right, let's take a break.